Hello, this is Ms. Cliffner with your video lesson for today. It's another lesson on rates and unit rates. So let's go ahead and get started. So here's a warm-up, practicing some of the figuring out what two numbers could be based on information about them. So you can go ahead and try these warm-up problems. I'm going to go ahead and get into the lesson video. Okay. So in the notes that we've been seeing so far, we've been talking about ratios and rates, and I want to show you that you can look at it sort of as categories, right? And so the first category was the general category of a ratio, which is a comparison of two quantities. Notice we can talk about how many teachers per student, how many inches per feet, which of course you know that there's 12 inches in 1 foot. But then there's rates, and rates there are ratios that have two different units. And so units, for instance, are how many apples, right, per pound, or how many claps somebody can do in a second. And then when you get into dividing, right, if this was, let's say somebody runs 24 feet, let's say it's a bug that crawls 24 feet in 4 minutes. That's a long way for a bug to crawl. But if I divided, I would find the unit rate of 6 feet, right, per 1 minute. So there's the broad category of ratios, and then specifically there's rates, and then even more specifically on rates, there's unit rates, which is when you divide and you find out how many for one of something, right? Dollars earned per hour, the miles your car can go per gallon, miles per hour, which is the speed limit. And then, of course, there is a unit cost, which is the price of something for 1 pound or 1 ounce. Or maybe in the good old days of cell phones, you used to pay money per minute instead of having these unlimited plans. Okay, so now let's look at using, again, we're using ratio tables to figure out what a better deal is. And so notice you've got a 2-pound bag for $1.98. You've got a 5-pound bag for $5.99. So the idea is I start with a table of putting in $1.98 per 2 pounds. And then I want to know how much it costs for 1 pound. So I divide by 2, right? This is the division pattern of dividing by 2. And I divide by 2, and I get 0.99. So it's dollars per 1 pound. And then the other package has 5 pounds for $5.99. $5.99 for 5 pounds. I want to know how much it costs for 1 pound, so I divide by 5, and I divide the top number by 5, right? We're just creating an equivalent ratio. And when I do that, I get 1.198, right, which rounds. So I look at the 8, I bump up the 9 to a 0, which means I also bump up the 1. So this is $1.20 per pound, and this was 99 cents per pound. So the better deal, of course, is the one that costs less per pound. Now I also want to talk about another way to do this. I'm just going to erase this. What you could do is, so what I was doing was dividing to find the unit rate, but you could figure out how much it costs for an equivalent amount of pounds, right? So let's say this was $1.98 for 2 pounds, and this is $5.99 for 5 pounds. I could find the common multiple of 10, right? So I could do this, and I can multiply by 5. And so let's see, if I multiply $1.98 times 5, if it was $2 times 5, it would be 10. But then there's 2 10 cents, so it's, let's see, 10 cents, so it's $9.90 for 10 pounds. And then I'm going to take the $5.99 and multiply this one times 2. Right? So I don't always have to find a unit rate. I'm finding the price for 10 pounds for both, right? Well, if I double the $5.99, if I round it up to 6, then I double it as 12, but then it's 2 cents away. So this was $11.98 for 5 pounds. I'm sorry, for 10 pounds. So you can find a common quantity, or you can find a unit rate. Okay, so here we go. This is an OYO, which is the better buy. Go ahead and pause the video and try these on your own. Again, if you want to find a common quantity, so I'm going to just put in the $4.95 for 3 sandwiches. If you want to find a common quantity, then you're looking at, if you buy 3 of something or 4 of something, a common multiple would be 12. So you'd have to figure out how much it costs for 12 of those sandwiches. I'm going to go ahead and do the unit rate. So I'm going to divide by 3 to get 1. And if I divide the bottom number by 3, I have to divide the top number by 3, and I get $1.65. So for these 3 sandwiches, it costs $1.65 per sandwich. And then when I divide the other example, I'm trying to figure out the price per 1 sandwich. I divide by 4, and I divide by 4. So I get $1.68. Okay, so this one's pretty close, right? This one is $1.68 per sandwich. And then I can put the word problem answer into a word sentence and say the better buy is 3 sandwiches for $4.95 because each sandwich is $1.65 instead of $1.68. Okay, it's only 3 cents cheaper, but it adds up. Okay, so I mentioned this last week, right? When we talk about per something, what we really mean is per 1, but we leave off the 1. And then I'm just showing you, again, in words, what I just showed you with the QD example. You can find a common quantity, or you can find a unit rate. Those are pretty much your 2 choices. So let's go ahead and look at another example where we're finding equivalent rates. So it says, are these rates equivalent or not? Show your reasoning. So again, to find if it's equivalent rates, I could look at 126 points for every 3 games and 210 points for every 5 games. I could multiply both of these times 5, right, to figure out how many points you would get in 15 games. I'm going to go ahead again and do the unit rate. So here's what I have. I have for, let's see, can I separate these? No. So I have 126 points divided by 3 games equals 42 points per game. And then I have, let me move that over, I have 210 points every 5 games, and it also equals 42 points per game. So here's what I could say, and I'm just going to go ahead and type this in. These 3 are equivalent because they have the same unit rate, right? We calculated the unit rate. If they have the same unit rate, then the rates are equivalent. So here's some OYOs. Decide whether the rates are equivalent or not. Let's go ahead and put that over there. Okay. Pause the video, try these on your own. You can find an equivalent amount of time or do a unit rate. So I think on this one, it makes sense to go ahead and multiply this times 4 to get 60 seconds, right? Sometimes it's easier to take your heart rate for only 15 seconds and then multiply it by 4 to get 60. So then this is times 4 and you get 68. And this one's already 68, right? So if I want to go ahead and multiply it by 1 and multiply it by 1, those numbers are not going to change. So the rates are equivalent because they both have 68 heartbeats in 60 seconds. And then, so let's just say equivalent rates of 68 beats. And I'm just going to go ahead and say that's 60 seconds. Okay, so here is, let's say you're comparing gas mileage, 96. One car goes 96 miles in 4 gallons, and the other one goes 380 in 15 gallons. So I might just go ahead and find a unit rate. So I'm going to divide this by 4, divide by 4. You get 24 miles per gallon, and then this one needs to be divided by 15 and divide by 15. So you get 25.3, and of course it keeps going. And I could say these are not equivalent. Not equivalent because the unit rates are different, right? And equivalent means they're going to have the same unit rate. Okay, sorry that one got a little messy. Okay, there's one more kind of example that I want to show you, and I sometimes use money as an example, but here's an example where there's a runner completing a marathon, right? In 210 minutes. So A says estimate the unit rate in miles per minute. So you would take the miles, 26.2, and divide by the 210 minutes. And so when I take a calculator and I do 26.2 divided by 210, I get that this person, the unit rate of, let's see, I'm going to do this down here. A is 0.125 miles per minute, right? And then if I want to look at the unit rate a different way, and I'm looking at minutes per mile for B, I'm going to flip the numbers upside down, and I'm going to do minutes here and then miles here, right? So it's two ways of approaching a unit rate, and so they're describing different things. So if I take 210 divided by 26.2, I get 8.02 minutes per mile. Okay, so two different ways of looking at this, right? How many miles can you run in 1 minute? Well, obviously, you can't run a mile in a minute, right? So that's why it's such a small decimal number. It's more likely in this instance that you might want to think about how many minutes it takes you to run a mile. And so then C says, another runner says, I averaged 10-minute miles in the marathon. So is this person talking about the kind of rate described in A or B? And what I want you to think about, this person says, I did a 10-minute mile. That means 10 minutes per mile. The order matches the B that says 8.02 minutes in a mile. And so when you are comparing unit rates, you want to make sure that you have the units in the right order in order to compare them, right? Order matters. Okay, good luck on homework.